All right, sweet. So let me share my screen and I'll run through the worksheet and then I'll let you guys get started. Okay, so our worksheet today is talking about one-to-one and inverse functions, which I know you've talked a little bit about in lecture, but this is just going to give you some examples and allow you to determine like if they're one-to-one and then go ahead and find the inverses of them if they are one-to-one. So these kind of go hand in hand because one-to-one functions have inverses. So first I'm going to start you off with 4 examples on the worksheet and you're going to determine are they one-to-one or not. And so there's not a ton of work that goes into that. It's really just like a yes or no. And then after that, I think I give you like maybe 6. Yeah, 6 functions down here to find the inverses of, and it does say in the directions, find the inverse of each of the following one-to-one functions. And if it's not one-to-one, don't attempt to find the inverse because there is no inverse. So that's why these kind of go hand in hand. So being able to look at these functions and maybe see like things that stand out and say this is definitely not one-to-one, so it doesn't have an inverse. So that's how they fit together. But first, let's just get started talking about 2 examples that I put together and determining if they're one-to-one. I went ahead and put the definition of one-to-one right next to where it says part 1. So I'll just read that off and talk about it really quick. So recall a function is one-to-one if any 2 different inputs in the domain correspond to 2 different outputs in the range. So then there's like kind of a more mathematical way of writing it next, but they mean the same thing. So in other words, if x1 and x2 are 2 different inputs, which means they're different values of a function f, then f is one-to-one if f of x1 doesn't equal f of x2. And that's just the output of x1 and the output of x2. So let's look at these examples that I put together and I said, are these one-to-one? So for A, I have the domain written here, 20, 25, 30, and 40. And then I have the range written down 380, 540, and 730. And then I've just got some arrows going there to tell you, what goes to what. So you just want to determine, is this one-to-one? And to reiterate that, that means that if you have 2 different inputs, they better go to 2 different outputs. So if I throw 2 different inputs in and I get the same thing out, that's a problem. That's not one-to-one. So to make this a little fun, I did a Zoom poll. So let's see. So for example A, just A right here, I'm going to launch the poll and I just ask, is A one-to-one? It's anonymous. It's just yes or no. And then maybe I'll ask someone if they want to like explain their answer. All right. Ooh. Okay, so I have almost everyone's voted. All right, yeah, everyone voted. So I'm going to end it. So the correct answer should be no. The function should not be one-to-one. So it looks like about 47% of you said no. So if you said no and you feel like sharing, why is this not one-to-one?
Because the 20 and the 25 both equal to 380, and that's not supposed to happen.
Yeah, perfect. That is exactly why. We have 2 different inputs, 20 and 25, and the output for those is the exact same thing. That is a straight violation of the definition because my definition says if x1 and x2 are 2 different inputs, f is one-to-one if the outputs are different. So like I said, 2 different inputs, they better go to 2 different outputs. So that's that. So yeah, A is not one-to-one, and that was a perfect explanation of why. So then for B, so I just wrote these as ordered pairs on this one. So we've got 1, 2, and just a reminder, the first little like number in the ordered pair is the input, and the second one's the output. So for this one, inputs 1, outputs 2. And then my next one is inputs 2, output is 8, and so on. So you can look at these, and then I'm going to do another poll and ask you if this is 1-to-1, yes or no. Okay, and I'm going to launch it and go ahead and answer it. It's anonymous again. Good. This one seems to be going good. First one's kind of a warm up, so yeah, okay. This one's going really good. So 18 people have answered and you've all said yes. So that's good. I'm gonna go ahead and end it. Okay, so obviously it's yes. There's not a whole lot of explanation here then if it's yes, because you can just see that for every different input, we have a different output. All right, great. So just to go ahead and answer, this one is no, and this one is yes. Okay, does anyone have any questions on 1-to-1 before I move on to finding the inverse function? Okay, so let's go down here. I just did an example that's find the inverse function, and this is f of x equals 4x plus 2. So there's a little bit of a process here to finding an inverse function, but like I said, just remember that a function needs to be 1-to-1 to have an inverse. So on all the examples on your worksheet, just glance at it and see, is there anything here that strikes me as like this is a problem for being 1-to-1? If not, proceed. So there is no issue with our function here for being 1-to-1. So I'm going to go ahead and find the inverse. So in terms of the process to do this, you're going to take whatever is here. So like f of x, or over here on my examples, we've got like g of x, k of x, whatever, that part right there. And we're going to change it to be y. So y equals 4x plus 2. So that is step 1. This is just going to make it a lot easier when we find our inverse. And then our next step is to switch the x and the y. So I'm just going to take and switch them. So now wherever there's a y, it's an x, and wherever there's an x, it's a y. So I now have x is equal to 4y plus 2. And then your last step is just to solve for y. And that's it. So you really got 3 steps. And the first one isn't even that much. You're just writing a y instead of f of x. And the next one, you're just flipping x and y. And then the last one, you're going to solve for y. So my first step to solve for y is to get y by itself. So I'm going to start by subtracting 2 and getting x minus 2 equals 4y. And then my final step is just to get y by itself is divide by 4. So now I've got x minus 2 over 4 equals y. And you can simplify this down a little further. This isn't incorrect, but you could keep going and get x over 4 minus 2 over 4 equals y. All I did was divide the x and the 2 by 4. And then you could see that this is x over 4 minus 1/2. So that's all. Those are the 3 steps. And then we know that f inverse of x is equal to x over 4 minus 1/2. And that's your final answer.
I don't know if you went over this, but how can you tell the function is 1-to-1 without like going through it, I guess?
Yeah, so you could so up here with my examples, I have some graphs, and you could like look at a graph of it. You'll notice some I don't want to give a spoiler away because you'll do this on the worksheet, but you'll notice some things about the functions, I don't know, there's some different types, like absolute value or parabolas, or there's just different types of functions, and you might like pick up on, oh, hey, this type of a function is not one-to-one. So if you kind of see that when you glance at some examples, you might look and be like, oh, I know that's not one-to-one, if that makes sense.
Okay. And so how do we know like when not to attempt one of the problems in part 2?
Yeah, to give you a hint, there's only one of them that you shouldn't attempt, which I guess there's a spoiler at the end and it literally says for question number 5. But to give you a hint, you shouldn't attempt that one. And I will tell you that I purposely put something up above here to help you answer that question. So once you go through the graphs and then when you get down to 5, that should help you answer why you weren't able to find an inverse.
Okay, thank you.
Yeah. Okay, are there any other questions on this? All right, so since there's no other questions, I'll stop my sharing and then I will pause the recording as well. Okay, so now that you guys have done these problems, there were kind of 2 maybe main like confusions or just like things that I wanted to address again. So initially I didn't want to just say this because I kind of wanted you guys to explore like the graphs on 3 and 4 and kind of identify like, hey, why is there a problem with these graphs? But now that you've taken a shot at it, it's good to know that a function is one-to-one if it passes the horizontal line test. So just like when you guys learned the vertical line test, this is basically the same thing. It's just a horizontal line. So that means that if I take a horizontal line and place it on my graph, if it hits more than one spot, it's not one-to-one. So I kind of wanted you guys to explore that concept on your own before I just told you, but it is good to know that these functions need to pass the horizontal line test to be one-to-one. So if you're given a function and you can envision the graph in your head, like maybe a parabola, and you're just like, oh, yeah, that definitely doesn't pass the horizontal line test, then that's great. So that's just like a quick way maybe in your head to think about it, which I told a few groups. And then another way of possibly attempting like questions 1 through 4 on part 1 that I was telling one group is if you see the same output twice and it doesn't correspond to the same input, that's a problem. So that's another way you can think about it is like, okay, do I see the same output appearing twice? And does it correspond to 2 different inputs? Because that's an issue too. So for example, if you happen to look at number 3, let me share my screen. This might be a little easier. Okay, so if we take a look at number 3 here, and we want to see, okay, do I have the same output twice? Right away, you can see that at 2, I get 2. And then at -2, I also get 2. So I have that f of -2 is 2, and f of 2 is also 2. So you can see I got the same output, but there were different inputs, which is a problem because my definition says if I have 2 different output or 2 different inputs, I better get 2 different outputs. And you can see that that violates it. So there's a few ways to like go about looking at a graph and just seeing, okay, do I have the same output with 2 different inputs or multiple different inputs in the case of number 4. So that's just a little tip that I was telling some groups to help. But with that being said, are there any questions that you guys would like me to go over? Any of the problems on here? I'm more than happy to. I would like you guys to finish the whole thing. They shouldn't be too terrible, so I'd like you guys to finish it all. So are there any ones with that being said that I can go over?
Can you go over number 1?
Okay, 1, and then who else?
I just had a quick question on 4 about like what to do with the x like has to be less than or equal to 0.
There's not anything really different that you have to do when you go about solving it. Yeah, there's not really like anything different in the process of solving it. So you can go about it the same way.
Okay, sounds good. Thanks.
Yeah. And then let's see. So, okay. I got okay, 2 people want me to go over 6. And then I also got number 1. So let me do 6 really quick. and then we'll hit number 1. All right, so let's do 6 here. So my first step, like always, is to just replace r of x with y. So now I have y is equal to 4 over x. My next step is just to switch my x and my y. So now I get x is equal to 4 over y. And then all you need to do is solve for y. So if you guys were working on 3, this is kind of a similar idea here to how you solve for y. So you want to go ahead and multiply both sides by y. And that's because this will cancel out, and then you'll be left with xy equals 4. And then we know we want to solve for y, so all we have to do is divide by x and get y equals 4 over x. And you can see this is actually what we started with. So this is one of those like interesting ones where actually the inverse is the same. So the answer is just 4 over x. Okay, and then wanted to go over number 1. So let me come up and do that one. I think this one threw a lot of people off because of the cube. So I'll go ahead and go over it as a group then. So my first step, always the same. F of x becomes y. We have y equals x minus 1 cubed plus 2. Then my next step is just to change, flip y and x. So I get x equals y minus 1 cubed plus 2. And now I just have to solve for y. So I was telling a few groups, you know that you want to solve for y, so you want to try and isolate that term with y in it. So a good first step would be to subtract 2 over. And then you're left with x minus 2 equals y minus 1 cubed. So x minus 2 equals y minus 1 cubed. So you want to figure out how can I undo cubing y minus 1. So just like with when you square something, undoing it is taking the square root. That's the same concept here with we have something cubed, so undoing it is just taking the cube root. So I want to take the cube root of both sides. So I get the cube root of x minus 2 is equal to y minus 1. And I think you guys know how to finish this one up, so I will let you finish this one up because you're just solving for y. Okay, with that being said, I will stop sharing really quick. Let's see. So Taylor, you asked a question on number 4 with the x is greater than or equal to 0. So I think that partially has to do with what you end up getting for the inverse. But if anyone has any questions on that that's further, you can always like send me an email or I can go over it next class.
So does that mean that it's because I'm looking at the x squared on number 4? Does that mean that it isn't a 1-to-1, or like basically should we solve for it?
You know what? You're right. You have a good